The STL provides three distinct types of queues. The stack object provides a last in, first out, or LIFO queue, where you push and pop items from the same side of the queue, and items are removed in the reverse order from which they were inserted. The queue object provides a first in, first out, or FIFO queue, where you push and pop from opposite sides of the queue, and items are removed in the same order in which they were inserted. The double-ended queue object, pronounced DEC, can push and pop from either side, allowing you to control the order in which items are inserted and removed. Let's take a look at how these work. We'll start with the stack class. Here I have a working copy of stack.cpp from Chapter 10 of the exercise files. A stack is what's called a container adapter, and it does not have iterators. If you need iterators, you want to use the container type directly. What a container adapter does is it takes another container and it adapts it for a particular use. And so in this case, you notice I start with a list container, and then I initialize the stack from that list. So stack is a container adapter, and it's adapting that list to its own uses. So I'm going to go ahead and build and run this, and then we'll step through it and see what it does. So you notice that my list is a list of integers, li, and my stack is a stack of integers from that li. And so li has a size and si has a size, and they're exactly the same. And now when I pop everything from si, li still has all 5 of its entries and si has none, because si is actually making a copy of the list. It's not using the list directly. So when I pop the items from the stack container, the pop method doesn't actually return the value. The value is returned from the top method before. And so if I want to actually see the things that I'm popping from it, I can use top to access that element before I pop it, which is what I'm doing here. And you notice that our list still has all of its entries after the stack has been emptied, because it initialized it from a list. I can also use the default stack, which actually uses the DEC object, and we'll get to the DEC object later in this lesson. And so here's a stack using a default object, a default container, and it's a stack of strings. And I add things to the stack by pushing elements on one by one. And so here I push 5 elements onto SS, and my size is 5, right there. And then I pop the elements, accessing them with top first, and you notice that they come out in the opposite order that they go in. That's because the stack is a last in, first out, or LIFO type of a queue. So that's the stack object. We're going to go ahead and delete our working copy, and I'm going to grab the queue.cpp instead. I'm going to run clean and build and run. And so queue is a last in, first out, or LIFO queue. It's also a container adapter. And so the same thing applies. I can initialize it from a list like here, or I can use the default queue, which again is the DEC queue, and we'll get to that next. And so this works exactly like the stack, except that it pops the elements in the reverse order. Well, actually, it pops them from the end of the queue, so they come out in the same order that they go in. And so in this case, you'll notice when I call pop, I'm getting the elements in the same order that they were in the list. And when I use the string version, I push 1, 2, 3, 4, 5, and they come out 1, 2, 3, 4, 5 in the same order that I put them in. Other than that, this works exactly the same as the stack. So I'm going to go ahead and delete that one, and we're going to take the DEC object. DEC stands for double-ended queue, and so it's spelled like that, but it's typically pronounced DEC. I'll go ahead and clean and run. And so this is a double-ended queue. And so you can push onto the back, you can push onto the front, and you can pop from the front or you can pop from the back. And so here I'm just pushing all of these elements on from the back. And so they're coming out in order 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my front is 1 and my back is 10. I can access them with an iterator like that. I can pop from the front. And when I pop from the front, you notice that one of the elements of the front is gone. I can pop from the back using pop back, and one of the elements from the back is gone. I can push front. There's a new front, and I can push back, and there's a new back. And so you can push and pop from both ends of a double-ended queue, or a deck. So the STL stack and queue classes are container adapters. They take an underlying container and they adapt it to last in, first out, or first in, first out queue. The default container that they'll use if you don't specify one is actually the deck queue. And that'll be used as a default container if you don't specify one for stack and queue. The deck class is a complete double-ended queue with random access iterator, and it's useful for many needs where a LIFO or a FIFO queue is not enough. So let's delete this working copy. And I'll run clean to get us prepared for the next lesson.